This video example is for Chapter 3. In this example, it says students in an intro stats course were asked to describe their politics as liberal, moderate, or conservative. Here are the results. So what's listed below, right here, this is called a contingency table or a two-way table, okay? But we use this a lot to describe categorical variables. Now the first question asks what percent of the class is male. The first thing we need to know, obviously for percentages, is what the total is. So if we look, and excuse me, I'm bad at doing this from the computer, but if we look, our total, or our grand total of students is 192. So when they ask what percent of the class is male, you're taking the total number of males, which is 115, divided by the total number of students, which is 192. And when I divide those two, I get about 0.599, or 59.9%. So B, what percent of the class considers themselves to be conservative? So this is the same idea. We're doing the same thing, except we're looking at total conservatives. So there are 27 people that would consider them to be conservative out of 192. So that gives us 0.141 or 14.1%. Now C is a little bit different, so you need to be careful. This one specifically asks what percent of all males in the class. So here we're not looking at the grand total because we're not looking at everyone in the class. Here we're looking at the percent of males. So we're going to be taking our total out of 115. So for C, what percent of all males consider themselves to be conservative? Well, since we're only looking at males, we're looking at this column, or this row, I should say, and 21 males consider themselves to be conservative. So we're going to do 21 divided by 115. And that gives us 0.183 or 18.3%. D, what percent of all students in the class are males who consider themselves to be conservative? So this one again goes back to the percent of all students. So we're going to look out of 192. But they specifically say out of all students, what percent are males who are conservative? So we're not going to take 27 because we don't care about all conservative students. We just care about the males who are conservative. So we're going to use 21 out of 192. So for this one, we're taking 21 out of 192. So that gives us 0.109 or 10.9%. Now E asks what percent of all females in the class are liberals. So this, if we go back to our table, we're only looking at females now. So our total is going to be out of 77. And it says what percent of all females in the class are liberal. So we're looking only at the liberal females. So we're doing 35 out of 77. Which is 0.455 or 45.5%. Now F asks the same thing. What percent of all males in the class are liberals? So again, here I'm just going to use a different color. We're looking at males, so only the males, and only the liberal males. So we're going to take 50 out of 115. So 50 divided by 115 is 0.435, or 43.5%. Now what I just did for E and F is I was starting to find conditional distributions. What a conditional distribution is it basically looks at the distribution or the percentages based on a certain characteristic. So what I'm going to do for the next part is specifically look at females and males separately. So the last question says, do politics and sex appear to be independent? Now, independent means that they have no effect on each other. If politics and sex truly have no effect on each other, the distributions between males and females and their political preference should be the same. Now, we can't just look at the numbers, like the 35, the 50, the 36, 44, 6, and 21, because the total number of males and females that participated in this survey are different. So that's why we have to turn them into percentages. So what I'm going to do, and I made a table just to help us to make it look a little more clear, is I'm going to find the conditional distribution for females based on their party preference, and then for males. So I've already done this with liberal females. So we did 35 out of 77, and that gave us 45.5%. So I would do the same thing for moderate. So there were 36 moderate females, so I take 36 divided by 77, and that gives me 46.8%. And then I would do the same thing for conservative. There were 6 females that said they were conservative, so 6 out of 77, and that gives me 7.8%. Now I go to the males. We already found the liberal males. We did 50 divided by 115, and that gave us 43.5%. Moderate, there were 44 males that said they were moderate, so 44 out of 115, and that was 38.3%. And then conservative males, there were 21 who said they were conservative. So that gives me 18.3%. Now, if these two variables, gender and politics, were independent, their percentages should be the same or very, very close, meaning within 1 to 2% of each other. Even though the liberal males and females, those percentages are within 2%, the moderate and the conservative, there are significant differences. So that means that there is an association between politics and sex, or that they are not independent. So in statistics, when we do something like this, we always write out sentences to explain our answers. So I'm going to write out how I would conclude this. So what I would say is, if politics and sex were independent, the conditional distributions of politics for males and females should be the same. For females, and I'm going to give specific examples. For females, 45.5% were liberal, 46.8% moderate, and 7.8% conservative. For males, 43.5% were liberal, 38.3% moderate, and 18.3% conservative. These percentages are different, so it appears that politics and sex are not independent. There is your video example for Chapter 3.